All right, so 8.3, we're doing arc, measure, and length. So a couple of objectives here. We're going to, yeah, just a couple, right? It's actually a few. We're going to identify minor arcs, major arcs, and semicircles, and use correct notation to name them. That's important. Find the measure of an arc using the arc addition postulate. Find the length of an arc and the perimeter of its related sector and segment.
Is an arc the little curve thing?
The arc is a curve. And 3, we're going to apply relationships between the measures of arcs, central angles, and intercepting chords in congruent circles. Whew. All right, so let's look at all these definitions first. All right, so a semicircle is half of a circle.
I would never guess.
I know. So what's the semicircle over in our diagram there? WY would be the semicircle. Or if we look at this, it says it's an arc measuring 180 degrees, named using 3 letters. WZY. Okay, so it's got, when it's stretched out that far, it's a little harder to see the arc, but there is an arc across there. It's not just a line. It is an arc. Okay. Then we have a minor arc. Okay. It's an arc measuring less than 180. It's named using only 2 letters, so like WX.
So couldn't WZ also work?
WZ could also work, yes. ZY, yes. Usually the arc is between, I mean, like that is an arc, but usually we have a segment there. So like WYX and XY would be.
And ZX. ZX is also
ZX would also be 1, yes. Okay. Now, the cool thing about these is its measure is equal to the measure of the central angle intercepting the arc. So that's what I was saying. Those are all arcs, but we usually have the central angle in there. So this arc, WX, is
equal to 60.
Is 60. Because the arc measure is equal to the measure of the central angle. So then what would XY be? Not 180, XY.
Oh, that you said W1. That would equal, oh, 120.
You know. How much? 120. Okay, because we said WZY, right, was a semicircle, because this was 180. So 180 minus 60, yep, would give us 120 for that one. Good. All right, next up we have a major arc. Is an arc measuring more than 180 degrees. It too is named using 3 letters. Okay, so let me erase some of this. So this says WZX. Okay, the direction is important because it's saying I'm going from W to Z to X. Okay, the Z is in the middle. So again, we have, let's look at it actually. Its measure is equal to 360 degrees minus the measure of the minor arc with the same endpoints. So in this case, right, this is the minor arc, right? That was 60. So this is 360 minus 60. So how much is WZX? 300. Or you could have, we know this is 180, and we solved and got this was 120, so we could have added those together as well. 180 plus 120 is 300. Either way you want to solve it is totally fine. Next up, we have adjacent arcs. What does adjacent mean? Lucas is adjacent to Caden. Right next to you. Okay? Arcs of the same circle that have exactly 1 point in common. So here, xy, let me erase these so we can break it down a little bit. Okay, so xy is adjacent to yz. They share this point right here in common. Good. All right, then we have arc addition postulate. The measure of an arc formed by the union of two adjacent arcs is the sum of the measure of the two adjacent arcs. Okay, we just did this. Okay, on this one. We took this arc right here, that semicircle, that was 180, and we took the arc right here, that was 120. We added them to up, and we got the 300 for that major arc. We just did this arc addition postulate. It's the same thing when we've done the angle addition postulate. Okay, we're just adding them. It's nothing new or different. So this example is saying the measure of xy plus the measure of yz is going to give you the measure of x to z. Does that make sense? Okay, so nothing like super brand new. Okay, then let's get into our examples. Example 1, find the measure of each arc in circle V. That's the circle up here. If the measure of YZ is 40, of arc YZ is 45 degrees, and the measure of angle WXV is 60 degrees. Okay, so why did I put this 45 degrees inside there when this said this is the measure of the arc YZ? Yep.
Why'd you put the 45? Because that's the degrees of
The interior.
no.
Yeah. Okay.
Isn't the area of the arc or the degrees how much is inside there?
Okay, so yeah, because remember that when we say the measure of the arc, it's the same as the measure of the central angle in there. Yes, good. So I could put it in there as that central angle.
So for A, could you do 360 minus 45?
Okay, so we want to do, let's see, I'm going to trace it. ZWY. So ZWY is going to be 360 minus 45. Ding, 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 ding. So 360 minus 45 equals what? 315. And I wrote this a little big. Okay, so 315 degrees. Good. All right, Justice, how about the next one?
Okay.
I'm going to erase here.
It's like the same thing but backwards. Okay, so
Well, kind of. It's Y, X,
yeah.
but it doesn't go to Z. It only goes to W. Y, X, W.
Hey, on D, Z to X, which way does it go?
Well, it has to be a minor arc to only use 2 letters, right? A semicircle or larger uses a major arc. Good question.
What is the size of the Y?
So the key in this one lies in the line.
Yeah.
That's a straight line that cuts your circle in. So that makes this what? So it's a semicircle, right? So it's just 180. Yep.
I didn't know it'd be that easy.
It is that easy. I like it. Okay. How about Caden? The C, the measure of arc ZW.
You want me to tell
And how you got it?
155.
Okay, how'd you get 155?
180 minus 45.
So we did 180 minus 45. Okay, so ZW. So we know this is 180, the line, and we subtracted the 45. Good. Okay. But 180 minus 45 is not
You said
150.
135.
Oh, he said 135? Okay. I'm sorry. I wrote 155. That's what I heard with this microphone on. My bad. All right, Lucas, we're back to you then for the measure of arc ZX. So this one's tricky. Which way does ZX go?
Which way does ZX go?
Yeah, because it can go Z to X this way if we go up from Z, or we could go down from Z. Which one is it? We know by how it's named. Because when we talked about our arcs, the semicircle, the minor arc, the major arc,
It'd go down
why would it go down?
because it's mine
Because it's a minor, because it's, how is it named?
with 2 letters.
With 2 letters, okay? So if it's half, if the arc is half the circle or larger, it always has to have 3 letters. Okay? If it's just the 2 letters, we know it's the minor arc. Good. So this is the minor arc because it's 2 letters. All right. And so we knew this one was 45. We said this one was 60. I'll put those back. So
Z to W is 135, right?
ZW is 135. That's a good call. Yep.
So would you add 60 and 45 and minus it by 35?
So like do 135 minus the quantity 60 plus 45?
Actually, no, you just
Well, hold on. ZW, pardon me. ZW 135 is this way. Is that what, did I get you, did we get confused? So what are you thinking then, Lucas?
add 60 and 135, which you get 195, and subtract it by 360, and you'll get
You'll get what?
$65.
165? Right? You'll get 165? Yep, you got it. You'll get 165. Very nice. Good work. Okay. Now we're gonna move up a little bit. Just be careful not to confuse arc measure and arc length. All right. So they're sometimes interchangeable, not always so much so. Okay. I can barely fit it on there. There we go. I think I got it all. All right. So be careful not to confuse arc measure and arc length. So arc measure is a degree measurement that's equal to the central angle that forms the arc. That's what we've been doing, calling it an arc measure. Arc length, on the other hand, is a fraction of the circumference of the circle. So the length, this formula, you might want to highlight it, circle it, put a box around it. The length equals theta. What is theta? Humpty Dumpty, yes. But what does it represent?
The percentage of the area.
Not the percentage of the area, or not the area. I think you have the right idea. You're just using the wrong words.
The sector, or
We use it to find the area of the sector. Yes, when we wanted that, it was in that formula. But what is theta? Okay, theta is the measure of the central angle.
So theta is the central angle.
Theta is the central angle. It's that degrees. So if it's a 60-degree angle, right? If this is a 60-degree angle, then theta is 60. If it was a 90-degree angle, theta would be 90. If it was a 25-degree angle, theta is 25. Okay, so it's theta divided by 360 times c, the circumference, which gets us to this theorem. If an arc of a circle with a radius r and a circumference, remember c equals 2 times pi times r, has a degree measure of theta, the arc length L is given by this formula. L equals theta divided by 360 times the circumference times c. So arc length, that's our formula for arc length. All right, and the reason that it's important is, like, if we look at these, the measure of arc AB and the measure of arc DE is 60 degrees, because that's the central angle measure. So those arcs are both the same. However, the length of the arc is different because the circles are different sizes. Okay, so that ends up being the length is 1/6 of, because 60, right? Where do we get the 1/6? Because remember, the formula was theta divided by 360. That's the only times c. That's the only fraction. So if I take theta, 60 divided by 360 reduces to 1/6. Yes. So this is 1/6 is 60 divided by 360 times our circumference, the 2 times pi times the radius. So the length of the smaller one is 2 times pi. The length of arc DE is 3 times pi because it had a longer radius. We prayed for too long and went over homework for too long. All right, let's see if we can finish example 2 then. Find the value of each variable. Find the value of each variable. So we've got L out here, right? Yeah. I know, I hate when they use L. It looks like a 1 or an I or something else, but it's not. It's an L. Okay, but so we're finding the arc length. The formula for our arc length is L equals theta divided by 360 times C.
No, just C. Sorry.
Okay, I was like C2. Okay, times C is our circumference. We don't know our length. We know our theta is 90.
So it's reduced to 1/4.
Okay, so that's reduced to 1/4. Awesome. Our circumference is 2 times pi times the radius. What's the radius? 10. So this would be 1/4 times 20 pi. What's 1/4 times 20?
5.
So L equals 5 pi yards. Kind of looks like a 2 there. I'm sorry about that. So 5 pi yards. Wonderful. Okay, let's try the next one. This time we have the length, right?
Mm-hmm.
We have to find theta, so we've got to use that same formula.
So
Length
pi.
equals...
So, wait, no, 5 pi equals.
Okay, sorry, I was going to write the formula. All right, so 5 pi equals theta divided by 360
C.
times C. That might be a little sucky. What's C? How do we find circumference? We have all the things we need. 2 times pi times the radius, 15. There you go. Yes. So then we've got 5 pi equals theta over 360 times 30 pi. We good with that? Okay, then what do we do?
Then do we divide the 30 and the 5?
Yep, we're going to divide by 30 pi on both sides. The pi's cancel.
Or is it, do we divide the 5?
Well, okay, we divide by the 30 pi. It's going to get rid of both of them because they stay together. Pi divided by pi is just 1. And then we reduce here.
Okay, so
1 over 6. So now we have 1/6 equals theta over 360.
Would it be 1 and 1/6 if you said pi equals 1 when they cancel out?
No, because it's 1/6 times 1.
Okay.
So that would just be 1/6.
So then theta equals 60.
So then theta equals 60. Good. Because you could multiply by 360 if you needed to, but we just did this one earlier and talked about it. So however you need to get that. Very nice.
You get 60 something.
How did he?
We did
Oh.
earlier with the 1/6.
So actually I'm going to write theta equals 60 degrees here. So I can have a little bit more room on the other one. All right, how about the last one?
Okay, it's a bell.
We're going to make it? No, it's already 33, isn't it? 34. Okay. All right, well, we will stop there. Let me alter your assignment a little bit. Don't.